Hey guys, welcome to chapter number 1 that is called as direction sense test. Well, talking about this chapter, today's chapter is very important because in any section under the in any reasoning section of any competitive exam, there will be probably 1 to 3 questions from direction sense test. All right. So this is a very important chapter. We are going to study about it today. So before that, I'm going to give you a brief introduction about it, about what we are going to study today. So first thing in introduction, what are directions? Let's not go to the chapter yet. What are directions? So as you know, there are totally 4 directions, that is north direction, east direction, south direction and west direction. So north, east, south and west, these are the 4 directions. We know sun always rises from here. All right, so this sun rises from here and sets over here. All right, sun sets over here. So basically what do we know is there are 4 directions, and to the 4 directions there are 4 sub directions over here. These are the main 4 directions, and there are 4 sub directions called as northeast, which lies between north and east, and there is we have the southeast direction, and then southwest direction, and then northwest directions. So you know, consider okay, these are the 8 directions totally. 4 are main ones and 4 are the sub ones, which lie between 2 main directions. All right, and then what we need to look after is what is direction sense test. So direction sense test are those kind of problems where we have where the questions are somewhat related to the direction. They revolve around these stuff. So whatever involves direction is called as direction sense test. All right, so let's study about it in brief. But before that, what I'd like to tell you is some points to remember. These points are very important. I have prepared it from the exam perspective. If you will be thorough with these points, definitely you will be saving a lot of time in examinations. So let's look at it one by one. All right, so first thing is angles. What are angles? As you know, if there are 2 lines and they meet at a point O, this is A, this is B, so whatever this thing, it's called as angle. All right, so this thing is called as angle. So consider this is a circle. Here is A, here is B, here is C, here is D, and this point it's called as, you know, like O. Consider it as a O. So from A, let's begin our journey. All right, let's begin our journey from here. So this forms a right angle triangle, right? This thing is a right angle triangle. If you draw a line over here, it's called as right angle triangle. So in a right angle triangle, what we know is the angle formed here in A, O and B, the angle here will be 90 degrees. All right, so the angle will be like 1 2 3 4 5 6 and so on, and 90 degrees till here. In a right angle triangle, the angle here will always be 90 degrees. So in the same way, from A, O and C will be having an angle of, you know, subtotal will be, even this will be 90 degrees. I mean B, O and C will be 90 degrees. In the same way, here here there is going to be 90, and here there is going to be 90. So when you consider that in an entire circle, it consists of 4 into 90 degrees, because 1 2 3 and 4 into 90 degrees. So there we have 4 of 90, that is 360 degrees. So completely in a circle we have 360 degree angles. So you always have to remember this thing, that a circle has 360 degrees. So if a person turns from this direction, turns and stands in the same way, he has turned 360 degrees. If he turns and looks, if he is looking at the south direction, you know, if he is looking at this direction, that is east, and if now he is looking at north direction, he has turned 90 degrees left side. All right, so you will have to remember this thing about angles. So next thing what we are going to look is clockwise and anti-clockwise direction. What are clockwise and what is anti-clockwise direction? Before that, let's have a look at a watch. So basically this is a watch, and we'll be having a 12 and a 3 here, a 6 here and a 9 over here. So and we'll be having 1 2, and in the same way we are going to have totally 12 hours. So how does a clock move? Consider you know, this is a hand of a clock and this is a center. In which way does a clock move? this point, it's going to move this side, right? It's going to move this side. So whatever moving this side, it's called as clockwise, I mean like a clock. All right, clockwise is nothing but which moves in accordance with the clock, and whichever goes opposite to it, that is this way, it's called as, you know, anti-clockwise direction. So if it moves in this manner, it's called as clockwise. If it moves in this manner, it's called as anti-clockwise. All right, so now tell me, this thing is clockwise, this thing is clockwise, and what is anti-clockwise? If something moves from this side, and this thing is anti-clockwise. All right, so this is clockwise, this is anti-clockwise. So you'll have to remember, do not get confused. It's a very important aspect. So this is clockwise and this is anti-clockwise directions. And next thing what we need to understand is with respect to. So with respect to, or WRT, it's one of the most important stuff where students go wrong. They get confused a lot about it. So before so always pay attention at this part, because in the question students do everything. All right, they solve the problem as per the given instruction, but what they do in hurry is they do not pay attention about with respect to. All right, so you'll have to pay attention here what I'm going to tell you. So now consider this 4 directions, and just take India. All right, so when you consider India map, it's somewhat like this, and what happens is here comes the southern states and all that. So in a rough sketch, this is a India map. So this is a Jammu and Kashmir is somewhere over here, and then Gujarat is somewhere over here, and south direction, that is Tamil Nadu. All right, so Tamil Nadu is somewhere here, and sister states, that is let's consider Assam. All right, Assam as here. All right, so now tell me, in India map, Jammu and Kashmir is to the north, Gujarat is to the west, Assam is to the east, and Tamil Nadu is to the south. Now tell me, in what direction is Jammu and Kashmir? Let me frame the question. In what direction is Jammu and Kashmir with respect to Gujarat? All right, we know Jammu and Kashmir is in north, we know that. All right, Jammu and Kashmir is in north, I know that. So tell me, where is Jammu and Kashmir with respect to Gujarat? I'm not asking with respect to India. All right, with respect to India, Jammu and Kashmir is in north, but with respect to Gujarat, where is Jammu and Kashmir? Exactly. So now what you need to do here is, whatever is given on the end part of it, right, with respect to Gujarat. So Gujarat, what you'll have to do is consider in the middle. Gujarat is over here. Then if Gujarat is over here in this direction, so in this direction, that makes it northeastern direction. So Jammu and Kashmir is in northeast direction to Gujarat. And now tell me, in which direction is Gujarat with respect to Jammu and Kashmir? So now what they are asking is, in which direction is Jammu and Kashmir with respect, Gujarat with respect to Jammu and Kashmir. So what you need to do is, you'll have to take this first and place Jammu and Kashmir over here. So Gujarat is in this direction now. All right, so this direction now, so this direction will give it as southwest. So Gujarat is in southwest direction of Jammu and Kashmir. So do not confuse with it. So be careful whenever you get this term in exam. All right, so next thing what we are going to do is left and right rule. So this is very important perspective. So before that, let's take a direction. See, for example, there are 2 people standing over here. So this is person A and person B. Person A is looking, this is person A and this is person B. Person B is looking towards north direction. He is facing this side. So these are his 2 legs and these are his hands. So where is his right? If he's looking this side, so his right hand will be this thing and his left hand will be this thing. All right. So now consider another person. He is facing towards south, that is he is facing towards this person. His face is over here. These are his 2 legs and these are his 2 hands. So which one is this hand? It will be right, and if which one will be this hand, it will be left. So now consider these two people are kind of watching Taj Mahal, and they're watching Taj Mahal and all that. So basically they're watching Taj Mahal. A person is standing here, a person is standing here, Taj Mahal is somewhere over here. So Taj Mahal is to the right side of B, and to A, Taj Mahal is on left side. So whatever that is to the right of this person will be to the left of this person, because they are facing opposite to each other. You will have to know this rule, it's very important. So now consider a person is looking at towards east direction. These are his two legs and these are his two hands. So this one will be right hand, this will be his left hand. But to a person facing south, these are his two hands, these are his two legs. So to a person who is facing south, the right side will be west and the left side will be east direction. All right, so this is very important thing, you'll have to remember it very carefully. So after that, let check this out, that is Pythagoras theorem. It's a very important point, as we all know Pythagoras theorem because we have studied it in school. So let's kind of get familiar with it. I mean, let's have a brief idea about it. So in a right angle triangle, this will be 90 degrees in a right angle triangle. So we'll be having this side, and this side. So in any right angle triangle, the side of the hypotenuse, this is called as hypotenuse. So in hypotenuse, that is the longest side, that is AC square, is always equal to the square of BC square plus AB square, that are the two sides. So the square of hypotenuse is equal to the sum of the squares of other two sides. So now consider that we have this is 3 centimeter long, 3 units long, and this is 4 units long. Right wise, if we have to find this thing, we don't know this. All right, so x square, or I'll just call it as AC square, is equal to, what is BC? BC is nothing but 4 square plus, and what is AB square? That is nothing but 3 square. That will make it 16 plus 3 square will be 9, that is equal to 25. So AC is going to be, all right, it was AC square. So AC is going to be root of 25, that is equal to AC is equal to 5. All right, so this is how you need to find out the problems while solving Pythagoras theorem. So that's about the most important problems to remember. And now I'll talk about the type of problems. Okay, after writing a lot of exams and also after analyzing many questions, what I found out that in any kind of problems on direction sense test arise from these 3 types. That is, questions are based on angles, questions are based on distance, and questions are based on Pythagoras theorem. Alright, so first thing, let's look at them one by one. That is, first thing, questions based on angles. In angles, what happens, what they give is, they first give you A, he's facing at a certain direction. Okay, let's just consider he's looking towards he's looking towards south, and now what they tell, these are the 4 direction, north, south, east and west. Okay, so A is looking towards south, and what they tell you is he moves 90 degree to the left. If this person, he's facing towards south, these will be his 2 legs, this will be his right hand, this will be his left hand. So sometimes they might give, okay, he turns like 45 degree to his right side, means 45 degree his right will be here. All right, and what if they give you he kind of turns 45 degree to his left, it will be this side. And they might give it in some other way as well. They might say he turns 90 degree to clockwise direction. So clockwise, so if he's looking here clockwise, the direction will be this side. So this, he has to move, he will be turning towards this direction, that is 90 degree clockwise direction. All right, this is very important, you need to understand this. All right, so this is these are the kind of problems that are based on angles. And before solving that, if you're getting this clockwise and right hand, clockwise and right hand, right? Clockwise and right hand, they are always considered as positive. anti-clockwise and left hand are always considered as negative thing. So what you need to do is, before solving everything, whatever they have given, first thing he turns right, first he then turns to the left, and they might have given 4 to 5 statements. What you need to do here is, first thing, if it is right and clockwise, you'll have to always add, like if they have given he turns 90 degree to the right, and then he turns 45 degree towards clockwise direction, they all come over here. And if they have given 45 degree to the anti-clockwise, so you'll have to consider, you'll always have to subtract these things. All right, so this and this are totally these are positive and these are negative. I'm going to show you in with respect to example how you need to solve them. First thing, let's have a look at example number 1. Now consider if a boy is facing south, he then turns 90 degree clockwise direction, he then turns 135 degree towards left. What direction is he facing now? First thing, we'll have to take a direction map over here. So now consider if a person is facing south, so which side is south? This side. So a person is standing over here and he's facing south. Okay, so here is a person and he's facing south. Okay, we know that these are his two legs, a right hand and a left hand. All right, a right hand and a left hand. So he's facing south. Okay, now he's facing south, and what he does is he turns 90 degree clockwise direction. So what is 90 degree clockwise direction? Clock always moves this side. So now he turns, okay, so his new direction is this side. He turns 90 degree towards clockwise direction. Okay, he's now turning 90 degree towards clockwise direction. Then what do they say is he turns 135 degree towards left. So what they are telling us is that he turns 135 degree towards his left. So now what he's doing is he's facing this side. These are his two legs, this is his right hand and this is his left hand, right? So what they are telling is he moves towards left. So now what he does is 135 degree towards left direction. All right, towards his left direction. So he turns this side to 135 degree. So this is nothing but 90 degrees. So from here, when he turns here, he has turned 90 degrees. So another 45 degree he has to go, right? Because 90 plus 35 is 90 plus 45 is equal to 135 given direction. So he will be turning, when he turns this side, he will have turned 135 degrees towards left side. So which direction is he facing now? So which will be this direction? This will always be southeast direction. So all right, so now he is looking towards southeast direction. So as I told you, another way, clockwise and right will be positive, and anti-clockwise and left will always be negative directions. So consider what they have given is 90 degree plus, and next thing we know is 135 degree left direction. So what will be minus 45. All right, so always remember minus 45. Okay, what do we have got here? Minus 45 degrees. We'll have to subtract 45 degrees. So now consider if he's standing here and looking towards this direction. All right, he is facing south. So what do we need to do here? We have to go back 45 degrees. So minus 45 is nothing but anti-clockwise or towards his left. All right, because negative is left or anti-clockwise. So this is his right hand, this is his left hand. So towards left or anti-clockwise direction, we will have to go 45 degrees. So this will be his 45 degree minus, that will be southeast direction. This is how you need to solve over here. So that's about the question number 1. Let's see another question or example number 2. That is, a girl is facing north. Okay, so first thing what we have to take here is direction map over here. So first thing, there's a girl. Okay, so a girl is standing here, she's facing north, and now we know that this girl is facing here. So this will be her right hand, this will be her left hand, these are legs, this is face. All right, so she turns 90 degrees towards her left. So what she does is she's turning 90 degrees towards her left. Okay, so what do we have here? towards her left will be minus 90 degrees. Okay, she then turns 45 degree in clockwise direction. So we have given key she has turned 45 degrees to her 45 degree to the clockwise direction. So clockwise, as I've told you, anti-clockwise and left will always be minus, clockwise and right direction will always be positive. So this is how I'm calculating this stuff. So 45 degree in clockwise direction. Okay, we know this now. If in clockwise direction, what she does is 45 degree. Okay, just a minute. First she was turning. Okay, first thing, she was turning towards north. She turned this direction, and what she does is 45 degree in clockwise direction. Clock always moves in this direction, right? Clock always moves in this direction. So what she does here is, next is she turns 45 degree 45 degree in clockwise direction. So 45 degree, so now she is clockwise direction, she is looking at this direction. What she does next is then 90 degrees in same direction. So another time what she does is again 90 degrees she is going to look. So when she is going to look here, it is going to be 45 degree. When she will be looking here, that is going to be a 90 degree between these two. Okay, so next what she does is 90 degree in same direction. So same direction will be plus 90 degree because that's clockwise direction. Then what she does is 45 degree in anti-clockwise direction. So what she does is, now she's already facing this side. What she does here is she goes anti-clockwise. Anti-clockwise will be this side, right? So how much she turns? 45 degree. So 45 degree she's going to look at this side. So now she's facing north side. Then what she does is, now she's facing this side. So she has gone minus 45 because anti-clockwise and left are minus. So she has gone minus 45. Then finally what she does is 180 degree in right direction. Now she was watching which side? Now she was watching here, right? Now she was watching, just a second, 90 degree was here. Now she was watching north. Now what she does is 180 degree in right direction. Okay, 180 degree is nothing but a flip over. Whatever here it is, it's going to come here. So next thing we know is she is facing towards her south direction. Okay, now we know if she is looking here, let's consider this will towards her right. So if she is facing this side will be her right. So this will be her 90 degrees, and another 90 degree will make it as here. So she is facing towards south direction. All right, so this is what we know about it. In what direction is she facing? She is facing south. So let's calculate here to 80 degree in right direction. So right will always be 180 degrees. Okay, so how do you calculate this? Minus 90 and plus 90 gets cancelled, plus 45 and minus 45 gets cancelled, so plus 180 remains. So what she was doing, she was facing north, right? A girl was facing north. Now what she does is 180 degree towards her right or clockwise direction. She turns like this. When she turns here, it will be 90 degree. When she makes another turn, that will be completely 180 degrees. So now she's facing south. This is how we need to solve the problems based on angles. Okay, let's now talk about the problems about distance. I mean the kind of problems we are given about distance. So first thing is, from her house a girl went 15 kilometers towards north, then 10 kilometers west, then 5 kilometers south, and finally turned east and covered a distance of 10 kilometers. What direction is she with respect to her house? As I told you guys, whenever we have this thing with respect to, be very careful about it, because you know a lot of students get confused about it. Let's try to solve this. From a house a girl went 15 kilometers to the north. Here is a girl. What she did was she went 15 kilometers to the north. All right, so she was somewhere over here, O. Now she reaches A. The distance will be 15 kilometers. Then what she does is, from here she's facing towards north, of course, 10 kilometers towards the west. So which direction is west? West, from here, consider this point is here, west will be to the left. So west, what she does is she travels 10 kilometers to the west. So now we have considered these two aspects and we have established a chart till here. Then 5 kilometers towards the south. When she reaches here, the south direction will be to the bottom. So from here what she does is she travels 5 kilometers, okay, and she has reached the point. This is point B, this is point C. She has reached here. She has reached here right now, 5 kilometers south, and then finally turned east and covered 10 kilometers. So what she does is finally she turns towards east. Which direction is east? This direction. If she is here, the east will be to the right side, and covered a distance of 10 kilometers. Okay, now she has traveled a distance of 10 kilometers. So because this is 10, even this is 10, so length has to be same. All right. So what direction is she with respect to her house? This is her house, right? In which direction is she with respect to her house? So while looking at that, what you need to do is consider this point as the center of that map. From here, in which direction her house is. So if her house is here, this will be her north, this will be her east, this will be her south, and this will be her west. So this part will be north direction. She is right now facing towards, she is in north direction with respect to her house. And if they have flipped the question like in which direction is her house with respect to girl, if they have asked this question, you'll have to consider girl as the middle over here, and her house will be towards the south. All right, so do not get confused with respect to. Let's look at example number 2. Out of 5 villages P, Q, R, S, T and T situated close to each other, P is to the west of R, R is to the south of P, T is to the north of Q, and S is to the south of T. In what direction is R with respect to T? Okay, let's first have a map. 5 villages, they are very close to each other. Okay, P is to the west of Q. So just look at this statement. What you need to do here is first, they are always to the west of something is to the in a direction of this. You'll always have to take Q first. Q you have taken, and what we have given is consider Q is to the center, P is to the west. So west will always be this side. So P is to the west of Q. Okay, we know that. Now next thing is R is to the south of P. So P, first consider P is over here, so R is to the south of it. So R will be to the south of P, and T is to the north of Q. So where is Q? Q is over here, and T is to the north of Q. So T will be over here. Then S is to the east of T. Alright, so we have given key T is over here and S is to the east of T. So S is over here. This is the map. Okay, we have established till here. So they have asked us what is the direction of R with respect to south. With respect to south, in the sense, first thing you need to take is south in the middle. So this will be north to south, this will be south, east and west. So to south, R will be in this direction. R is to this direction, that is southwest. So answer will be southwest direction. So R is to the southwest of S. So this is how we need to solve that. And let's look at the kind of problems about Pythagoras theorem. First thing, a person starts from A and goes 3 kilometers east. Before that, we'll have to look at the map. First thing, a person starts from A. This is a point A, and a person starts and goes 3 kilometers towards east. What he does is he travels 3 kilometers to east and reaches B. Consider it, okay? If they're not given it in statement, just assume it, so that will be easy for you. So now he is looking at this direction and he has reached B. 3 kilometers he has traveled. What he does is he turns left. What will be his left? If a person is looking this direction, this will be his left hand, this one will be his right hand, these are his two legs. So if he's, and we have known this thing, then he turns to his left and travels 9 kilometers. So what he does is he turns left and he travels 9 kilometers and he reaches C. Okay, just assume it. So he has 9 kilometers he has this will be 3 km, this will be 9 km, and turns left, and again he turns left and travels 15 kilometers. So again he turns. Now this time what happens, he is facing this side, these are his two legs, this is his left, this is his right. So towards left again he travels 15 kilometers. So what he does is 15 kilometers he travels to his left and reaches the destination. So this is his destination. Okay, so now this is destination, this was his initial point, this is his final point or destination. How far is he from his initial point? So what they are asking us is, what is the distance between this is what they are asking us. So now how do you need to solve this? We'll have to make a right angle here, because when before solving a Pythagoras sum, you'll have to have a right angle triangle. So where is the right angle triangle? This, okay, this can be formed as a right angle triangle. Okay, so because they are all perpendicular to each other, the angle between here is always 90 degree, right? So this thing is 3 kilometers and this is parallel to it, so this has to be, of course, 3 kilometers. So if it is 3 and it completely is 15, what plus 3 is going to make it 15? So from here to here it has to be 12, from here to here it is 3. So 12 plus 3 is combinedly going to give us 15 kilometers. So let's now we have a smaller triangle. Now we have a smaller triangle, that is this part. This part I have taken it here for convenience. Let's consider it as O. Okay, we have O, A and D over here. So what do we know here? This length is 12 kilometers and this length is something what we need to find out, and this thing, if this is parallel to this, if this is 9 kilometers, this has to be 9 kilometers. So we know the length, that is 9 kilometers. So according to this, according to all this stuff, what have I told you about a right angle triangle? What I've told you is, in any right angle triangle, the side of hypotenuse, that is OD square, is equal to OA square plus OD square. That is nothing but OA square is 9 square plus 9 square plus 12 square, that is equal to 81 plus 144, that is going to give us 225. Then OD square, this one was OD square, so OD has to be root of 225. So OD is 15 kilometers. So we have established that he is 15 kilometers away from the initial point or his house. So the direction here, that was 15 kilometers. So this is how you need to solve it. Okay, this one was example number 1. Now let's look at example number 2. A person starts from A. First thing, take a direction. A person starts from A, okay, then goes 3 kilometers to the north. North is this direction, so he goes 3 kilometers to the north, and then he turns okay, he has one, we have established this, he turns right and travel 14 kilometers. So if he is looking this side, this will be his right hand, this will be his left hand, this will be his legs. So he looks at the right and travels 14 kilometers. Okay, then what he does is he reaches this point and then he turns left and travels 4 kilometers. So this time if he is facing this side, this will be his left, this will be his right, these are his two legs. If he turns left and travels 4 kilometer, okay, now till here the direction, the diagram is this type. Then he finally turns east. Okay, now he turns east. East is, if he is here, east will be to his right. Turns towards east and travels 10 kilometers. Okay, now what he does is he travels 10 kilometers. Now what they ask is, after this much, what is the shorter distance available from initial point to final point? So this is his final point. This is where he had started, that is initial point, that is A. So what we need to find out is, consider this final point as B and this as A. what they are asking you is what is the distance between this thing. Okay, from A to B, what is the distance? So before solving this, what you need to do is you'll have to imagine a right angle triangle. Okay, this is a right angle triangle. This completely is going to make it a right angle triangle. So consider this point as C. Okay, consider this as C. So what do we know here? This is the shortest distance available and they have asked us the length of it. So we'll have to first calculate what is the length of this thing and what is the length of this thing. So we know from here to here it is 10, and what will be this distance? It is going to be parallel to this, so consider it as 14. So 10 plus 14 is going to give us 24. Okay, so this side is 24 units, that is for 24 kilometers, and this direction will be, that is what they have told us is this is 3 and this will be parallel to this, so these both will combinedly give us 7 kilometers, 24 kilometers and 7 kilometer. That is hypotenuse is AB square is equal to CB square plus AC square. That is nothing but 24. CB is 24 square plus AC is nothing but 7 square. That is going to make it, I think, 576 plus 49. That is AB square is equal to 625. Then AB has to be root of 625. Then AB has got to be 25. So the length, the shortest distance will be 25 kilometers. So this is how you need to solve it. And thanks for watching this video, guys, and please check out another video, that is 1.b, which I'm going to upload shortly based upon the problems of this chapter. So whatever kind of interesting chapters I find, I'm going to upload them. And if you're searching for the best recommended books for your preparation, I've mentioned them in the description below. Please do have a check at it. And then for more videos helping prepare you in an organized way, do subscribe to our channel and press that bell icon and follow us on FB page and do not miss any update. So support this channel and share this channel link with your friends. And thank you and have a nice day.